All right, so this is going on page 49 when we're done. So we're going to start with a, oh, I don't need this up there. We're going to start with a function that I'm just giving you the points of it, and so let's plot it. So we've got -4, -5, -2, 0, 0, 3, 2, 4, 4, 3, and 6, 0. Wait, that's wrong. Dang it. Why is this? Does this say reflections at the top? Oh, poop. I must have been I think I was a victim of cutting and pasting. That is not the order pairs. I typed this in myself. Where the heck did I get those numbers? Okay. Everybody use pencil where you can erase it? Anybody need a new one because you used pen and it's my fault? I got more if you need a pen. Did you use a pen? Anybody? Look at you all using pencil. I'm proud of you. Okay, so let's start over. I'm going to give you a different little T-chart. Good thing we have room here because I would just totally, I don't even know where that came from. All right, so X, Y. Here's what I really want, so that this is -4, -2, 0, 2, 4, and 6 for the X values. And then 4, 1, 3, 0, -3, and -3. Honestly, I have no idea where I even got those numbers. Okay. All right, does everybody have that written down? So I'm going to scroll back up and graph mine. All right, so now what I really want, I mean, really, in the grand scheme of things, it wouldn't matter. It's just that there's certain things happening with this graph to make sure that we understand what's going on. I don't want that to. Oh God, so -4, 4. I'm not using this. -2, 1, 0, 3, 2, 0, 4, -3, and 6. Okay. And then we're going to connect the dots so it should look like this. That was what I was aiming for there, which means I think you have numbers on the inside too. Those are probably wrong as well. Oh, good, I left it blank. Yay me. Except I think there's not enough blanks now, but that's okay. All right, so we all got that? So that's our original function, and we are going to look at different reflections. Yes, you sure I even wrote the. All right. We're going to look at different reflections with this. So we're going to go to the inside of the notes, and we're going to redo the same thing. I just wanted the original one on the outside. So I've got to give you these again anyway. So -4, oh my goodness. So it's -4. Oh my gosh, it's like it's a Monday. Okay, -4, 4, -2, 1, 0, 3, 2, 0, 4, -3, 6, -3. Okay. Those are the points. So we're just going to plot those same points again because I wanted you to be able to, you need to be able to see it with everything else. -2, 1, 0, 3, 2, 0. Okay. We can plot those points, right? So this is just the original function. So now we're going to go down here and we're going to look at negative f of x, right? So if it's negative f of x, what changes? The y. So our x values stay the same, so we can just rewrite our x values. They are negative 4, negative 2, 0, 2, 4, and 6. And then the only thing that changes is the sign on the y values, right? Okay, so that means that this is going to be a negative 4, negative 1, 3, 0, 3, and 3. Now, when you change the sign on the y, that is a reflection in what? The what? X-axis. Very good. So when you change the sign on y, this is a reflection in the x-axis. Right? It's a reflection in the x-axis. That means for every xy that you had originally, it maps to x negative y. So we have our points. All we had to do was go in here and change the signs. So now we can come back over here and graph them. Goes to negative 4, negative 4, negative 2, negative 1. And then we connect the dots. So this is what we're doing if we just have points. Like we just look at the t-chart and we just do it that way. But if you're looking at it from a parent function perspective, kind of do the same thing but with your key points and just understand what the reflection is supposed to look like in the x-axis. Okay, we all good? Any questions? All right. So let's look at this one. When we transform it this way and all we do is change the sign on x, what is this? Reflection in the y-axis. Good. So this is a reflection in the y-axis because for every xy, there is a negative xy. So this time our y values stay the same. So our original y values that you see up there are 4, 1, 3, 0, negative 3, and negative 3. Okay, so all the y values stay the same. We just change the sign on x because we're reflecting it in the y-axis. That would be a negative 4. No, it would not because it was a negative 4. 4, 2, 0, negative 2, negative 4, negative 6. So I go to 4, 4, 2, 1, 3. So it's important that you understand not just that this means you change the sign on x, because that's clear, that's what's happening, right? But if you don't have a table of values and you don't have any x's to just change, you need to know that it is a reflection in the y-axis so that you can know what the resulting figure is supposed to look like. Okay, we all good? Any questions? Awesome. All right, so then the next one, it's like this. So here, what doesn't change? The x. So our x's are the same. So let's rewrite our x's. They were negative 4, negative 2, 0, 2, 4, 6. Because all f of x is y, right? That should be like a no-brainer at this point. So our y value, the number itself stays the same, but what happens to the signs? They're all positive, right? It's not just that they change, but they all end up being positive, because that's what absolute value means, right? So this is, I can't see my original ones. On your paper, like if you have it open, the one reason we redid it on the inside was so that the top left one is always the original one that you can refer back to, and you wouldn't have to go back to the front. You have to look on here because I can't see mine. So the first ones were positive anyway. So we've got 4, 1, 3, 0, and then 3, 3. So when we plot it, we've got negative 4, 4, negative 2, 1, 0, 3, 2, 0, 4, 3, and 6, 3. Now, is this a transformation that you did in Algebra 2? Did you do this with parent functions in Algebra 2? Do you remember? Because it's not just a straight up reflection in X or Y, right? Did the entire function get reflected? No. Did part of it get reflected? Yes, but then the other part stayed the same, right? So in this case here, since we've got the absolute value of f of x, which is the absolute value of y, that means you cannot have any negative y's at all. So if it was already positive, it stays positive. If it was negative, then it gets reflected in the x-axis. Does that make sense? So it's only a partial reflection. Good. So this is what we call the, this is the absolute value of y. All right, I decided I want an answer from y'all because y'all just stared at me. Did you do this in Algebra 2 or not? Like it looks brand new to you? Totally new, you don't know it. Okay, that's okay, because I don't know the answer to those questions. But when y'all just stare at me, it makes me wonder. I don't know. It kind of makes me think that you probably didn't because it doesn't look familiar. So let's look at what's happening. If you look back here, I mean, you can look at both of yours at the same time. Here's our original function, right? So all of this up here, this is all positive, right? The y's are all positive, so they get to stay positive. But the stuff that was negative, that is the part that gets reflected in the y-axis. Okay, does that make sense? So it's just part of it. It's not the whole thing. It's a partial reflection. Okay, and you can see what's happening there. Good? Just like you fold it up. Or if we had drawn it on tracing paper or like on patty paper, and then we could fold it on the axis, and then whatever you see through there, there's your function. Okay, good. So now let's look at this next one. Here, what changes? The x, okay? And the y does not. So let's just rewrite our original y's, which was 4, 1, 3, 0, negative 3, and negative 3. Oh, no. That's not going to work out that way, is it? No, that's right. Actually, no, we don't need that. What we need to look at is when x is positive, we're going to have to change these. That's okay. We'll change them as we go. We've got x. X is negative 4, right? When x is negative 4, y is positive 4, right? But x isn't really negative 4. We're changing that negative 4 to what? Positive 4. And when x is positive 4, when it's positive 4, is it 4? Look at your original chart. When x is positive 4, what is y? Negative 3. So this is not 4 anymore. This is negative 3. Does that make sense? Because we plug in a negative 4, we're actually evaluating a positive 4. Does that make sense to you? When I plug in a negative 4 here, I'm evaluating a positive 4. And when you look at your original chart, that doesn't give you a positive 4. The positive 4 gives you the negative 3. Does that make sense? And so when we plug in the x is still negative though. I did this wrong. When we plug in the negative 4, right, it becomes positive, right? So we're actually taking f of a positive 4. And when you look at your chart, f of positive 4 is not positive 4, it's negative 3, right? Our next x value was negative 2. When we plug in a -2, we're actually evaluating a +2. You look at your original chart. When you evaluate a +2, what do you get? 0. Okay? See how it's a good thing. I'm leaving them there on purpose, and because we're marking them out and redoing them, because I want you to see that they're different. Right, because you're taking, this is the f of the absolute value of x. So when you plug in the -4, you have to take the absolute value before you evaluate it. So the f of the absolute value of -4 is f of +4. Does that make sense? Then we plug in the -2, f of the absolute value of -2 is f of +2. So that's why the -2 isn't 1 anymore. The -2 is 0. Okay? And when we plug in the -4, we actually evaluate +4, so that's not 4, it's -3. These are the ones that are changing. Okay? So x is staying, we're plugging in x, it actually changes the y value. All right? And then our next x value was 0. What's the absolute value of 0? 0. So is it still 3? Yes. So then we plug in a 2. And absolute value of 2 is 2, right? So we're still evaluating 2, so this one stays the same. Then we plug in a 4 and a 6. And since these were positive, the y values stay the same. Oh my God, what's wrong with me? Exactly. So these are the same, exactly the same, right? When you plug in the negative, you're actually evaluating the positive, so it has to match up with these down here. Okay, does that make sense? So let's look at what's happening graphically. This gives me, when we plot these, we've got -4, -3, -2, 0, 0, 3, 2, 0, 4, -3, 6, -3. Okay. So we connect the dots. Notice that this didn't just change a sign. It completely changed a number, too. Okay, yes, ma'am. -4, when you plug in an x of a -4, right, you're taking the absolute value of -4 before you evaluate it. So the f of the absolute value of -4 is actually the f of +4. Does that make sense to you? Okay, so let me say this again. We're taking if you take f of 4, that means I'm plugging in 4, right? I'm taking f of the absolute value of -4. So you have to work from the inside out, right? So I have to take the absolute value before I can do anything else. So the absolute value of -4 is 4. So the f of -4 is actually the f of 4 because I'm taking the absolute value. And so when I look at my original function, when x is 4, y is -3. Okay? So instead of me getting the 4 out of it, because I had to take the absolute value before I evaluated it, it gives me this value here, not this value here. Yeah, you just take that. Yeah, exactly. Basically, I'm still plugging in the negatives. Like my x, I can put in a -x, but it changes it to a positive before it gets evaluated. Okay, does that make sense? So any of the values that I had that went with those aren't necessarily right anymore. Okay, so these now have to match, and these now have to match. Okay, oh crap, wrong one. It moves when I do that. I wonder if that didn't make any sense there. There we go. So these have to match. Oh my God, it's like I've never taught before. I can't even see it. these have to match, and these have to match. Right, so notice the y values, they're the same. Because anytime you plug in a negative, it's going to match the positive from the original one. On the x, yes. Yes, yes, yes. Okay, so the x's are staying the same. I'm evaluating a different x, though. We good? To find the y. That one's a little confusing, but I made it confusing from the beginning. I'm sorry. Any other questions? And then apparently I don't know how to use the Promethean board, so that makes it worse. Okay, so what I wanted the words in here, and I've written all this other stuff, which is fine. But this is the absolute value of x, obviously. All right, are we sort of good? I'll probably have to I'll come back and re-explain that one at the end, or maybe on Monday again if you need to think about it for a little bit. All right, so this right here, what does this mean? Inverse. So this is the inverse function, but it's with our reflection. So what is it a reflection in? What line? Y equals x. Okay, so this is the reflection in y equals x, which is our parent function. We know that, right? You're not going to make my head explode like you did a couple years ago when we went over this. And it makes me sad for society. Okay, so that's what we're reflecting it in, basically. Right? When you do a reflection in the line y equals x, or when you do the inverse of a function, what is all that you do? How do you do it? You flip the what? X and y. So if you're going to actually find it, like if I give you an equation and I say find the inverse, you switch x and y and solve for y, right? That's because for every x, y, and it wasn't consistent doing this on all of them, it maps to yx. So you just take your original ones and you switch them around. So your y's become x, your x becomes y. So this is 4, 1, 3, 0, negative 3, negative 3, negative 4, negative 2, 0, 2, 4, and 6. So we're not going to draw both of them up here, and you don't necessarily have to draw that line in. I just want you to think about where the reflection actually is. So we get 2, 4. Hopefully I'm right on this. My goodness. 2, 0, 2, 4. Oh, see? 4, 6. There is your inverse. Okay. Any questions? Do I need to do another absolute value of x? Because I completely confused everybody. Let's, what I will do though, since we have it, if you go back to the front, we have these random points that I didn't really intend on using for anything. And so if we use this, a little smaller. We're going to use this, and let's do that real quick because I think we have time. And I just want to make sure. I feel bad because I feel like I've confused everybody now. All right, so we're going to use this one, even though we didn't use it for anything else. All right, and we're going to find f of the absolute value of x. Now, wait, that is this. Are those the numbers? Oh, my x values are right. It was my y values I didn't change. Now I see what I did. Okay, now I see what I did. I cut and pasted and those were right. It was these I didn't go back and change. Okay, sorry. Well, it's okay. We're going to use these anyway. So my x values still stay the same. Right? 0, 2, 4, and 6. So now, when I plug in my x, right, it's a -4 that I'm plugging in, but I have to take the absolute value before I evaluate it. So my answer is not -5. The absolute value of -4 is 4, so my new y value for that x value matches this one, and it is 3. Okay, does that make sense? It does not match the numbers inside, because remember, these numbers were wrong. I made them up, or I don't know where the heck they came from. -2, I take the absolute value of it before I evaluate it, so the answer is not 0. The answer is going to be 4. And then the rest stay the same. Does that help a little bit on what to do? Make it make a little bit more sense, hopefully. And if you need to write it out like this, f of the absolute value of -4 equals f of 4, I mean, that's what's happening, so that you can see it a little bit better. Okay? Any questions? All right. Then go ahead and glue this in. We're going to start with a warm-up on this on Monday for sure, just to make sure that we get it